The results from a recent study showed apparent association between diet high in saturated fat and refined carbohydrates, aka the Western diet, and very specific negative changes in brain structure. Previous researchers really paved way and warranted such study. While the same group of authors first published their results back in 2010, where it was found that the typical Western diet, high in processed food and refined carbohydrates, is associated with greater disposition for various mental disorders. Hippocampus is widely regarded as this specific brain region involved in mood regulation and depression, and the important role hippocampus plays in the association between diet and mental and cognitive health was well studied and established by using animal models. The authors here conducted this retrospective cohort study where existing data from a longitudinal community study called Personality and Total Health Through Life Project was collected and analyzed. Two waves of food frequency questionnaire completion and MRI assessment were done within a 4-year interval, and 255 participants aged 60 to 64 at baseline out of 2,551 individuals in total completed both waves of both forms of assessment and were included in the study. In the food frequency questionnaire, a total of 180 food items were labeled into two groups. Is either the prudent or healthy diet, which includes fresh vegetables, salad, fruit, and fish, etc., or the Western or unhealthy diet, which includes roast meat, sausages, burgers, chips, soft drinks, you name it. As expected, smaller hippocampus were seen independently, both in groups scoring lower on healthy diet and those scoring higher on unhealthy diet. The authors also modeled hippocampal volume for 3 categories based on the responders' dietary factor score, and showed significant differences in left hippocampal volume between healthy and average and between unhealthy and average diets. One of the most profound findings on the impact of dietary pattern is that between healthy and an unhealthy diet group, there was a difference in hippocampal volume corresponding to 62% of average decline of natural aging over a 4-year period. These observed hippocampal shrinkage may be explained by inflammatory processes and neurodegeneration. Brain-derived neurotrophic factor, aka BDNF, is found to promote neurogenesis, whose level is reduced in high-fat and sucrose diet in animal models. This was found to lead to hippocampus-related cognitive and memory deficits. BDNF level may be restored by dietary adjustments. Mediterranean diet, for example, have been shown to improve cognitive function and depression. Although there has been animal studies supporting changes in hippocampus following diet changes, this particular study is really significant and unique in that it links dietary patterns with specific changes in human brain, paving way for potential dietary interventions targeting hippocampal atrophy. We should applaud this study for including a reasonably large number of participants for its kind, and for drawing data from a large and longitudinal study that will represent the population. However, it's apparent that not all confounds can be taken into consideration and adjusted for in observational studies like this one. It may well be that regular exercising among participants, rather than or in addition to a healthy diet, had benefits on hippocampus in the current study. Therefore, we cannot say with certainty that unhealthy Western diet is causing shrunken hippocampus. Other news articles out there often uses article such as "Can a Western diet shrink the hippocampus?" which implies misleading causal relationship and should be avoided. Also, some news articles also hints at that even eating healthy will improve mental functioning, which may be true, but is beyond the scope of the study and should be avoided again because there's is not mentioned in the study. In addition, only data from older individuals were included, so it's doubtful if the outcome applies to everyone at all ages. As well, the study is rather a pilot study that only measured hippocampal volume without looking into its impact on any related functions such as memory and cognitive functioning among participants.